Hi, my name is Lucio Simoni. I'm the engineering manager for BC Group. In this video today, we've got a special feature for you. We're going to demonstrate our ESU Analyzer Series and show you some of the differences between the models. Behind me here, I have our Tower of Power. We've got 4 of our more popular ESU analyzers. From the top to bottom, we have our ESU 2050, we have the ESU 2350, ESU 2400, and ESU 2400H. Now we'll see some similarities and differences between these models. Again, starting from the top, we have the 2050, which is very portable, but it doesn't have any loads. So it gets all of its readings through the current transformer, which I have here connected to our ESU 2350 input. So with this one, you have to have external loads. And this was actually designed as a replacement for an older Fluke millivolt meter, an RF millivolt meter that went obsolete. So all it was is a millivolt meter. And then we got a request to add in more features, such as being able to measure milliamps and watts and display all the readings that the biomed needs, rather than just the millivolts that the old meter could do. So moving down, we have the 2350. This one is our latest model. And what we'll see here between the 2350 and the 2400s is that we have more inputs on the front. So what we've done is it still has internal loads. It's a smaller unit and it has fewer loads. So the load resolution is in 5 ohms, but it's smaller, so it's lighter, easier to move around, but it doesn't have all the automation that the 2400 and the H does. So instead of being able to automatically switch our load between leakage loads and power loads and REM loads, we have to manually make connections to different places on the front of the unit. But if, as far as compatibility with other units in the field in this price range, we have the maximum features and available settings that we have for this unit. We do have auto sequences built in. It just doesn't have the full automation that we get with the other units. So moving down to the 2400, this unit has 1 ohm load increments. It also has a pulsed mode measurement. It can measure a basic pulse mode like the ConMed 5000, where the output of the generator just pulses on or off. Then we have, this one does have automation inside as far as where the load is connected. When you're doing leakage loads, it'll move the power load to earth ground. It'll move it to active to the CQM input for doing power loads. So we do get that automation in this unit. It does also have auto sequences. And then if we look down at the 2400H, what this adds is a more powerful analog circuit. So we have the ability to measure more advanced waveforms from generators like the Olympus ESG 400 that we have here today. And we'll display why this unit is needed to read some of those waveforms. So let's talk a little bit about the connections. I've already got all of my connections made for this demonstration. The output of the generator is going to the active input of my 2350. Now that's also where I have the current transformer for the 2050, again, because it does not have any internal loads. We're using the 2350 as our load. So we have the internal variable load connected between the active input and the dispersive or CQM terminal. I'm going to go to the measure RF energy. We can see our configuration here. We are set up for an internal load of 200 ohms. Okay, so then if we move down to our 2400, we have the output of the 2350 connected to the active input on our 2400. On this unit, if we go to the load configuration, we can see that we are set to an external load. So internally, this load is shorted out. We have 0 ohms inside, and we have 200 ohms that is set to our 2350. The output of the 2400 is then connected to the input of our 2400H. And if we look at that load configuration, we also can see that it is set to an external load of 200 ohms. So our load here is between active and the CQM terminals. So then we have the output of that analyzer is the return path back to our generator. And that completes the circuit that is the complete load for the generator. So now that we have the loads configured, let's talk a little bit about the configuration and settings on each of the analyzers. On the 2050, we can see that a milliamp measurement is being displayed. I have the load set to 200 ohms, and I'm set for a fast averaging speed. So if we look at our 2350, we can see that we have very similar settings. We have our milliamp selected, and that's the only measurement in the display. We have fast averaging set, and we have our load set for 200 ohms. Now we can see additional settings for isolated or ground reference generator. For this unit that we're testing here, the Force FX, we have an isolated generator selected. Looking at our 2400 display, we can see a few more options in our display, but it's very similar to the 2350. We have our averaging set. I'm going to change that to fast averaging so that we can look at similar measurements on each of our units. We have we're measuring a continuous waveform and not a pulsed waveform. We have our load set to 200 ohms, and we're also set to an isolated load. Going down to our 2400H, we can see, again, a similar set of settings on our display. I'm going to again change the measurement averaging to fast, and we have 200 ohms load set and an isolated generator selected. Now let's talk about the generators that we have on display here. From top to bottom, we have the Olympus ESG 400. This unit has a lot of new pulsed waveforms that we don't see in all of our generators. So we've got it set to pulse cut slow, and that's going to be one of the pulse mode 3 settings that we have on the 2400H. And we'll show what happens when we try and put that signal into the other analyzers, how they measure that signal. So here we have the FT10. This is one of the newest generators from Covidian. This represents a lot of design changes and improvements in electrosurgery generators that has happened over the years. And then we'll look at the Force FX. Now this one has been around for quite a while. A lot of you have the Valley Lab Force FX in your hospitals. You'll be testing these for preventive maintenance. And so I've got this one set for coag spray, and we'll see what this waveform does and how we can best measure this waveform. And we're also going to demonstrate the pure cut on that generator. So what we'll see is the Force FX, it calculated the output power, and it adjusts its output power at a slower rate than the other generators. And so we'll see how that affects the analyzers and what kind of settings we need on the analyzers to properly measure these outputs. So now I'm going to activate the generator for a cut output. We've got 120 watts set, and we're going to look at the milliamp output that is measured by all of our analyzers. So here we can see the 2400, it gives us a reading, but it's moving around a little bit, right? So it's bouncing somewhere between 740 and 765 in that range. We've got the 2050, which is also doing similar measurements, and the 2400H and the 2350 are giving us much more stable readings. Now, what's happening here is these are all giving accurate measurements. This is what the analyzers are measuring. That's what's coming out of the generator. Now, I mentioned this is a fairly older unit, so its ability to update the output, it's a little bit slower than the newer generators. So it's analyzing the load, and it's applying power to generate the 120 watts that you have selected on the output. But what's actually happening is from cycle to cycle, it's adjusting the output. So over time, the amplitude changes a little bit. And what we're seeing is the measurement sampling rate of the ESU 2400 and the 2050. So again, our technology has changed over the years, just like theirs has. So that output is being adjusted over time. And so we're seeing those adjustments in the 2050 and the 2400 because our sampling window is smaller. When we looked at the 2400H and the 2350, we had a more stable measurement. Even though they were all set to fast averaging, we had a more stable measurement because we're measuring more data. We have more time that we're sampling. So let's take a look. I think we'll really get a good example of this when we do the coag spray. Now, the coag spray it's a burst output, and the time between the cycles of the output is variant. So they adjust the timing, and that will really show up here on our different units. So we go to coag spray at 120 watts, and we'll see here that even the 2400H and the 2350 now, they're moving around a little bit as well. And again, we have everything set to fast averaging. And the 2400 and the 2050, they're moving around more than they used to. Again, that's because of that variant output from the generator. It's doing what it's supposed to. The analyzers are doing what they're supposed to. They're telling you what they're measuring at that instant in time when they take a measurement. So what I'd like to do is change these. Again, I'm trying to analyze this generator. Is it operating properly? What measurement do I write down for that? Because they were all kind of bouncing around. So what I would do first is go to a different averaging mode. So just like our DMM, we can change how much averaging we do for each of these units. Okay, so now we go to slow averaging. This is going to try and average multiple readings together to get a more stable measurement. Now we're not, in the case of the 2400 and the 2050, we're not sampling any more time. We're just taking those samples and mathematically averaging them together. For the 2350 and the 2400, we're actually extending our sampling window and measuring more samples of data to give us a more stable reading. So let's look at what happens here. Now we do the coag spray again, and look at that. Our 2400H and the 2050 are pretty solid. They're not bouncing around much at all. There's a slight drift over time, but they're not bouncing up and down. The 2400 and the 2050 are better, but again, they're still drifting over time just a little bit. Okay, so that's a way to get a better reading off of coag spray, is to change the averaging rate, and we can see how that averaging affects the different analyzers. So now let's look at a slightly newer generator and see how that improvement in the output of the generator can be reflected in our measurements. So we're going to connect to the FT10. Now they've really improved the sampling rate of the generator, and now they're doing more adjustments on the output to create a more stable output from the generator. We're going to go back to fast averaging on all of our analyzers just to do this very similar analysis that we did before. Okay, so now let's look at what happens with the FT10. Now I've got this one connected to our foot switch output from our ESU Analyzer, so I can configure the output for a duration and what signal we want to measure. So first we're going to do cut, just like we did before. I'm going to go ahead and trigger the generator. And now we can see that even in fast mode, all of our analyzers are giving us a very stable measurement. And that really represents the improvement in technology, the improvement in the output from the generator. So it's sampling the load more, it's sampling its output faster. And so it's creating a more stable output. And we can really see that here. We've got fast averaging on all of our analyzers. The 2050 and the 2400 are sampling a much less data, and even they're even able to give us a nice stable reading. We'll just demonstrate that one more time here. Another 10 seconds of measurement. Now let's look at the coag spray. So I'm going to change this to spray just so we have the same output that we did from the Force FX. And let's see how this output performs. So I'm going to configure 2400 for a coag. It's going to trigger coag for 10 seconds. And let's take a look at that. So now we can see we have the 2400H and the 2350, again, are giving us nice stable readings. They're sampling more data. They're able to make a more stable calculation, even in the fast mode. And the 2400 and the 2050 are bouncing around a little bit because they're responding to the coag spray and the timing of that output. Now what we can do, we can still go to even a medium or a slow averaging on our 2050 and 2400. Let's see if that will get us to a nice stable reading on coag spray. And so there we go. Now we can get a nice stable measurement with all of our analyzers, even in coag spray, okay? So what I'd like to do now is take a look at one of the more advanced waveforms that the generators are producing. This is the ESG 400. It's going to be a pulse cut output. So this output, actually, it's pretty interesting. There's 3 different amplitudes in the output. So for a set period of time, it's at one amplitude, then it jumps to a much higher amplitude for a short period of time, and then it turns off for a short period of time. So that's the output cycle and the output waveform. And you know, these generators, they're in the 400 kilohertz range. So when I say it's off, I mean it's off for several milliseconds. So that's hundreds of cycles, if not thousands of cycles of the sine wave output. So we're going to make our connections to the Olympus generator. And this one is going to tell me, hey, we detected that you have a non-split electrode. Again, it's showing me that I have a non-split electrode. My cable, yep, they're shorted together. So that's correct, that's fine. We have to tell it that we're okay with that. And so now we're going to put out a pulsed waveform. So let's see what happens with these analyzers when they get that output. So this one I have connected to the 2400H. So let's configure that foot switch for 10 seconds of cut and trigger the generator. We can even hear it pulsing. So that's the burst of output. And we can see sporadically, depending on when it samples, it may be sampling at that high amplitude, it may be sampling at the middle amplitude, it may be sampling at 0. So, you know, we get readings on our analyzer, we're saying, what's going on? Something's not working right. Well, everything's doing its job, it's just that we don't have the right configuration. So I may look at my 2350 and I can see I don't have a setting for pulsed or continuous mode. Okay, so in order to meet this price range, that feature had to come out. So the 2350 does not have a pulsed mode measurement. If we look at the 2400, we do have a pulsed mode, and we just have pulsed or continuous. So I go into pulsed mode, and we'll see what this analyzer can do. Now if we go to the 2400H, if we go into our pulsed mode, we can see we even have more measurement modes. We go into pulsed mode, and now I've got 3 different pulse modes to choose from. So if we look at on the screen, it shows us a representation of the different pulse modes. So in pulse mode 1, the output from the generator is just on or off, okay? And that represents the pulse mode of the 2050, the 2050P and the 2400. That's the pulse mode that they can measure. The 2400H adds 2 additional modes, and one of them is where we alternate between 2 amplitudes. So on the screen here we can see P1 and P2. That alternates between 2 different amplitudes, and then we have a pulse mode 3, which toggles between 3 different amplitudes. So to have 3 different amplitudes, we need 2 different thresholds. I've got those configured on the screen here. And that's going to allow me to measure all three of those outputs from the generator and give us a really good representation of what's happening. So I'm going to accept these changes. So now that I have my pulse mode 3 configuration set, we can see on the screen we've got a lot more readings available to us. On the top left, we show the overall milliamps total for the entire waveform. We've got our overall watts, and we've got the frequency that's measured. And then we have detailed information about the 3 different pulse segments that we're configuring. We've got milliamps, watts, the duration, the time, and then the duty cycle of each one of these segments. Now we have the 2050 also set to pulse mode, and we can see the settings that are on the screen here are all relative to a single pulse, a single cycle. So we get a time on and a time off, and that's all we have. Let's see what happens when we apply the output from the Olympus generator with this advanced pulse waveform to these 4 analyzers. So we can see that the 2050 and the 2350, they're reading, but the readings are bouncing around quite a bit because they may be reading the high pulse, they may be reading the middle pulse, and they may be reading 0, all depending on when they're sampling the waveform. And now when we look at that same waveform here on the 2400, we have a similar situation where it's detecting the pulse, but is it detecting, the high pulse or the middle pulse? And it only knows when it's on or when it's off. So that's affecting these readings. They're not really very stable. They're moving around quite a bit based on when it's detecting the pulse. If we look at the 2400H screen, we can see that it can sample all 3 segments of that waveform. I'm going to go ahead and press the hold button here so we can lock these readings on the screen even after the generator turns off. So now we can see all of the readings on the screen here. We've got each of the different segments. We've got pulse 1, which is our highest pulse. It's 1100 milliamps and 274 watts. We've got our middle pulse, which is 454 milliamps, and that's what we were seeing on the 2350 and the 2050. It was toggling between these 2 measurements, and then we've got a short period of time of 9 milliseconds, 9.6 milliseconds, where it's completely off. So that's why these other analyzers can't get a nice stable reading, because it really depends on what portion of these segments when it triggers its measurement and it takes its reading. But when we set it up properly for the 2400H, we can now get a stable measurement and analyze each segment of that output waveform. Here at BC Group, we like to provide as many different options as possible for you so that you only have to buy the equipment that you need. And now we can see how each of the analyzers perform with different generators and also different waveforms that the generators are putting out. So based on what you need to measure, you can pick the equipment that meets your needs.
Thank you for watching this BC Group International production. For more information about our extensive line of BC biomedical products and products from our vendor alliances, browse BC Marketplace online at bcgroupstore.com. BC Group, we are your one-stop biomed shop.